Welcome back to the .NET Way. You're watching episode 18 of our .NET Core interview series. Today, we're diving into one of the most exciting features in ASP.NET Core, SignalR. This is the technology behind live chats, instant notifications, multiplayer games, real-time dashboards, and collaborative applications. Let's ask Aarohi how experienced developers use SignalR in production and what problems developers usually face while building real-time systems.
Thanks. SignalR is one of those technologies that completely changes how users experience applications. Instead of constantly refreshing pages or polling APIs every few seconds, the server can instantly push updates to connected clients in real time. But once systems scale, SignalR introduces entirely new architectural challenges around connections, scaling, security, distributed messaging, and performance.
Aarohi, let's start with the basics. What exactly is SignalR?
SignalR is a real-time communication library in ASP.NET Core that enables bidirectional communication between the server and connected clients. That means the server can instantly push data to browsers, mobile apps, or desktop applications without waiting for the client to request it manually. Internally, SignalR abstracts technologies like WebSockets, server-sent events, long polling, and automatically chooses the best available transport depending on browser and server support.
Where have you seen SignalR used in production?
Almost everywhere real-time updates are important. Companies use SignalR for chat systems, admin dashboards, delivery tracking, trading systems, support ticket notifications, IoT monitoring, collaborative tools, and multiplayer gaming. Modern users expect instant updates now. Polling APIs every few seconds feels outdated and inefficient.
Can you show us the core implementation?
A SignalR hub acts like a real-time communication endpoint between the server and connected clients. Clients can call server methods, and the server can push messages back instantly. In this example, every connected client receives the message immediately through clients.all.
How does the front end connect to SignalR?
The front end uses the SignalR JavaScript client to establish a persistent connection with the server. Once connected, the browser can continuously receive real-time updates without repeatedly calling APIs. This creates a much smoother user experience.
What's happening internally behind the scenes?
SignalR first tries to establish a WebSocket connection because it provides full duplex communication with minimal overhead. If WebSockets are unavailable, SignalR automatically falls back to server-sent events or long polling. This transport abstraction is one of the biggest reasons developers love SignalR, because we don't need to manually manage low-level networking logic.
Why does SignalR prefer WebSockets first?
WebSockets create a persistent TCP connection between the client and server. Unlike HTTP polling, the connection stays open continuously, which dramatically reduces latency and unnecessary network traffic. That makes WebSockets ideal for chat systems, live dashboards, trading systems, and multiplayer applications.
What if I don't want to broadcast to everyone?
Absolutely. SignalR supports multiple messaging patterns. Clients.all is used to broadcast messages to every connected client. Clients.user allows sending messages to a specific user. And clients.group is used to send messages to a particular group or chat room. Groups are extremely useful for chat rooms, team dashboards, multiplayer games, and role-based notifications.
How do users join chat rooms or groups?
SignalR groups are logical collections of connected clients. When users join a room, SignalR internally tracks their connection IDs and allows messages to be broadcast only to that group. This is one of the most common patterns in chat applications.
Are SignalR endpoints public by default?
No, SignalR hubs should absolutely be secured in production. We typically protect them using JWT authentication or cookie authentication. Without proper authorization, attackers could connect to hubs and receive sensitive real-time data.
Can mobile apps authenticate using tokens?
Yes, this is extremely common in production. The front end attaches the JWT token during connection creation, and ASP.NET Core validates it using the normal authentication middleware. This allows SignalR to integrate cleanly with modern APIs and mobile applications.
What happens if the internet disconnects temporarily?
Network interruptions are very common in real-world systems. SignalR supports automatic reconnection, so the client can reconnect without requiring users to refresh the page manually. This becomes critical in mobile apps and unstable networks.
What happens if the application runs on multiple servers?
This is where things become more complicated. SignalR connections are stored in server memory. So if server A sends a message, server B doesn't automatically know about it. Without synchronization, users connected to different servers may stop receiving updates correctly. That's why distributed SignalR systems require a backplane.
What is a SignalR backplane?
A backplane synchronizes SignalR messages across multiple servers. Redis is the most common option. When one server publishes a SignalR event, Redis distributes that message to all other servers, so every connected client receives updates correctly.
Why do companies use Azure SignalR service?
Managing thousands of WebSocket connections manually becomes extremely difficult at scale. Azure SignalR service handles connection management, scaling, load balancing, connection persistence. This removes massive infrastructure complexity from enterprise applications.
How do chat apps show online users?
Every SignalR client receives a unique connection ID. Developers typically map user IDs to active connections using in-memory caches, Redis, or distributed storage. This enables presence tracking, online indicators, typing indicators, and active session monitoring.
What problems appear at scale?
One of the biggest mistakes is broadcasting huge messages to thousands of clients simultaneously. Another common issue is keeping too many idle WebSocket connections alive without proper scaling infrastructure. SignalR systems must carefully manage payload size, connection count, serialization overhead, memory usage, message frequency. Otherwise, servers can become overloaded very quickly.
What if clients send too many messages?
Without protection, malicious users can flood SignalR hubs with thousands of messages per second. That can exhaust CPU, memory, and network resources. Production systems often implement rate limiting, throttling, message validation, queue buffering to protect real-time infrastructure.
How does SignalR fit into microservices?
Very well, but architecture becomes more advanced. In microservices environments, SignalR often acts as a centralized real-time gateway, while backend services publish events through message brokers like RabbitMQ or Kafka. That allows multiple services to trigger real-time updates without tightly coupling systems together.
Tell us about a real project where you used SignalR.
In one enterprise dashboard system, we used SignalR to push live order updates, fraud alerts, support tickets, and admin notifications instantly to connected users. Before SignalR, the front end was polling APIs every few seconds, which created unnecessary traffic and delayed updates. After migrating to SignalR, the system became faster, more responsive, and significantly more scalable.
Let's finish with your production checklist.
The biggest rule is this: real-time systems behave very differently from normal APIs. Once thousands of persistent connections are active simultaneously, scalability, memory usage, security, and distributed coordination become much more important. If developers design SignalR systems carefully, they can build incredibly responsive real-time experiences that scale reliably in production.
Brilliant, Aarohi. SignalR is one of the most exciting technologies in ASP.NET Core, and now we understand how real-time systems actually work behind the scenes. If this episode helped you, don't forget to like, comment, and subscribe to the .NET Way. In episode 19, we'll discuss microservices architecture and learn how enterprise systems break down monoliths into scalable services. Thanks for watching. See you in the next one.